the Laplace-Runge-Lenz vectors. So we are going to derive these equations later. Then once we have these equations, you can move to the left hand side here. It becomes d dt r dot cross L minus g m sub 1 m sub 2 e sub r is 0. So inside of the parentheses have to be the constant. We name it, this is a C, is a r dot cross L minus g m sub 1 m sub 2 e sub r is a constant vectors. This constant vector is called the Laplace-Runge-Lenz vectors. Three scientists independently derived these constant vectors. So we are going to prove the equation, this equation. So confirm the following equations. R dot cross L is expressed R2 dot cross L plus R dot cross dl dt. But dl dt is 0. So we have only the first terms. Then for the second derivatives, we have a mu r2 dot. This is the equation of motions. Minus g m sub 1 m sub 2 r cube r vectors. So we substitute here. Then it becomes minus g m sub 1 m sub 2 over mu r cube r vector cross L. Then minus g m sub 1 m sub 2 over mu r cube. This is r e r cross mu r square theta dot e sub z. So this is equal to the L. R is equal to this one. Then mu is going to be cancelled out. R cube is going to be cancelled out. So we have minus g m sub 1 m sub 2 theta dot e sub r cross e sub z. And e sub r, e sub z is a minus e sub theta. So it becomes g m sub 1 m sub 2 theta dot e sub theta. It derives. And the e sub r, if you remember, the e sub r is expressed as equations is cosine theta e sub x plus sine theta e sub y, and the e sub theta is expressed minus sine theta e sub x plus cosine theta e sub y. If you find the derivative of the e sub r dot, it becomes minus theta dot sine theta e sub x plus theta dot cosine theta e sub y. So except the theta dot, it's becoming e sub theta. So this is equal to theta dot e sub theta. Okay. So r er dot is equal to the theta dot e theta. So this is theta dot e theta is equal to er dot. So G m sub 1 m sub 2 is a constant. So this means d dt G m sub 1 m sub 2 E sub r. So we derived this formulas. So we proved practice 2.7. Okay. Then we'd like to move to the next practice 2.8. Demonstrate the following equations. L square. This is exactly equal to the L. Definition of the L. We have to use this formula. A dot B cross C is equal to the B dot C cross A equals C dot A cross B. We have these formulas because these quantities, if you consider 3 A vectors, B vectors, and C vectors. Actually, these quantities correspond to the volume. A cross B is correspond to the areas and they directed these directions and take a scalar product. This becomes the height. It's come to the volumes. So using these relations, then you can move to the from this to the here. So it becomes a mu r. It becomes a first, and the r dot comes to the here, and the L comes to the here. We derive the constant C is equal r dot cross L minus G m sub 1 m sub 2 E sub r. So this is exactly same with the distance. And we use a Laplace-Runge-Lenz vector of the C plus G m sub 1 m sub 2. So L squares is expressed mu r vectors scalar product Laplace-Runge-Lenz vector plus G m sub 1 m sub 2 E sub r. So we proved these formulas. This is the end of this session.